Hello and welcome back to Geology. Today I want to continue on with Chapter 10 on geologic time, and in particular this next section on correlation. So when we look at stratigraphic formations, remember not everywhere on Earth has a complete record of all the geologic strata. So we have to correlate one region to another one, right? And so we use this process called stratigraphy, which is a study interpretation of the rock record sequence. And we always want to start with the oldest unit on the bottom and work our way to the youngest unit on the top, just like you would expect with the principle of superposition, right? And what we'll do, we're going to chart out these stratigraphic formations. And formations are geologic units, either single beds, thick beds, or sequence of beds of a specific rock type or group of rocks that can be traced over a large region. They'll have some spatial distribution. And in terms of those stratigraphic groups, there will be several adjacent formations in succession may be lumped together. And for example, we talked about that Uncar group in the Grand Canyon, which is that older Precambrian sedimentary rock where there's an angular unconformity between the Grand Canyon group and then this Uncar group. Now, when we're looking at outcrops and formations, we have this concept of a contact, a geologic contact, and it's a boundary between two formations, and it represents a change in energy and environment, right? For example, when we look at the limestone, the red wall limestone, well, that's marine, that's relatively deep water, whereas the supai, these are shales and sands, so these are near shore, shallow water deposits, right? So there's a change in environment, and that would be the geologic contact between the two formations, right? Now, when we talk about structural geology later on about faults and folds, there are other types of contacts like fault contacts, right? And there's also these erosional contacts, these disconformities, unconformities, nonconformities. Those are also a different type of contact. So looking at the Grand Canyon, just looking at its model here, remember we're always starting with the oldest rocks here. We mentioned that this Vishnu schist is a metamorphic rock, and it's about 1700 MA. Or 1.7 billion years old. The Zoroaster granite, which are these intrusive that penetrate into the Vishnu schist, are about 1400 million years old, right? And so, and then we have this major nonconformity right here, the contact between the Grand Canyon group here, these younger rocks, which are flat-lying, and then these rocks that formed at depth, right, through metamorphism and plutonism, right? And so that's the nonconformity. And then we have the top-eat sandstone, Bright Angel Shale, Mauve Limestone, and so on all the way to the top there, right? And we're looking at basically the most of the Paleozoic era here. But along the way, we see that we have a disconformity between the Mauve Limestone and the limestone, right? So that's an erosional event there. And so note that the strata are parallel on both sides, so it's a disconformity. Another thing to note here, as we're going from the top-eat sandstone here, we know that this is some shoreline, right? The environment for a beach, shallow water, some shore of a sea that was encroaching. A shale, well, this is shallow water, so we know we're in a little deeper waters. And then obviously the limestone here, these are going to be the deep waters. So what we find just in the sequence from top-eats to Bright Angel Shale to Mauve Limestones, we have one of those marine transgressions. Transgression, right? Where sea level has risen, right? There's a sea level rise. So there's a good example. Just those three units in the Grand Canyon group are showing this marine transgression. Now, going back to the top up here and thinking about our stratigraphy and correlation, which I'll do in a moment. But first, I want to do something called these geologic time puzzles. Now, what these geologic time puzzles require, they require us to use the principles of relative dating, superposition, cross-cutting relations, inclusions, to determine the order of events, the stratigraphy. And there will be several of these quizzes. I have at least 3 that I'll put on the exam. And not only do we use the relative time principles, but we also use the unconformities are really important. So let's look at some of these here. So here's the first one I want to look at. It's these block models, and they have different formations. Here we have formation E, and then there's formation B, G. So there's different letters in here. So we see this is G here. So it looks like we know that B is going to be beneath G, right? So this is G, this is B, and so E. So remember, we want to figure out the oldest formation first, right? So based on this, looks like E is the oldest unit. And that's because I'm using the principle of superposition to tell me that it's at the bottom. But then I'm gonna progress up. I'm gonna see that B is younger than E, G is younger than B, then we have F, and then above F, we're going to have this sandstone. Remember, the stipple pattern is probably a sandstone, which is letter C. So we got B, G, this is F, because it matches this F right here, and this is C, and then looks like right on top of C, if this is C here, I must have H on top of that, right? So this would be H right there. So there is my sequence just based on superposition. So these units I organize based on the principle of superposition, right? One on top of the other. Now, the next thing I notice is that all these strata are faulted. So this is a fault, and we haven't talked about faults yet. And again, when we do geologic structures, we'll talk about them. But here, we have this side of the fault has moved up, whereas this side has moved down. And geologists call this a reverse fault, where there's squeezing or compression, right? But we know that the fault came after all these strata. So note that here it's faulting U. So we're going to call this fault U would be the next thing. And I do that because based on the cross-cutting relationship, the fault cross-cut these older units. Then I have this erosion event, right, which is an unconformity, but note that the strata are parallel on both sides. So I'm going to have this erosion R, but really what it is, it's a disconformity. I'm going to call it disconformity R, because that's the next unit that occurs. That's this erosion event here. And then we see the last 2 formations, D and A. So that's how we're going to decipher these relative time diagrams, these geologic puzzles, using both the principles of superposition. In fact, for both fault U and disconformity R, those are cross-cutting relations because the unconformity cross-cuts the fault. So I know it's younger. So these 2 are going to be the X cut I'll put here, right? So I use cross-cutting relationships to determine the relative ages of those 2. So that's one model there. It can get more complicated. I'll have another one similar to this one, where we have we're going to combine not just relative time dating principles, but also we'll talk about absolute time dating and radiometric isotope dating. We'll get to that in a moment, but let's just do the relative time ages here, right? So I have I describe what the units are here. For example, unit F is this metamorphic rock, right? And I see that there's an unconformity above it, right? An erosion of it. So that unconformity kind of cuts across F and P, so it must be younger. But then I see, in terms of P and F, I see an inclusion of F inside of P. So that means F must be older than P. And besides, this being a metamorphic rock, whatever metamorphic process metamorphosed this rock should have metamorphosed anything that's older. So we see that P is a granite, and P is not metamorphic. All right, then we'll have to talk about this fault G over here, right? So the oldest thing we're going to put at the bottom down here is our letter F, which is our metamorphic rock. Then there's the intrusive P. And then note that the unconformity, in fact, it's called unconformity X to X prime here. Note that it cross-cuts that fault, G. So G would be the fault here. And then we're going to have that X to X prime, and it's going to be a non-conformity. I'll put non-conformity, right? Because it's crystalline and metamorphic basement here underneath sediments up over here. Then as I move along here, I'm going to use a principle of superposition. I'm going to have B, R, A, and H. So B, R, H, and A, right? Because those are in a sequence, superposition. And I put a note here that the that basalt sill M, this one here, is going to be younger of the sequence, B, R, H, and A, because it coincided with the tectonic folding of those units. So it's going to come afterwards, which means that would be my next unit here, M, the sill, right? This intrusion. Now, the next unit that's happening, I see that there's this unconformity. And I note that there's two different angles here. So I'm going to have y to y prime, which is this y to y prime, and this is an angular unconformity. I'll put angle right there. It's an angular because I see two different angles. And then above that, I'm going to have E, X, and D. So E, X, and D. E, X, and D. And note that, again, I'm using superposition for that. But I see that there's this fault now that cuts at least D, but it does not cut this unconformity up here. So that's going to be my next unit, which is K. And there's another fault there. And this fault in particular is another one of those reverse faults, right? Where we call this side up here above the fault called the hanging wall. The hanging wall block is moving up there. And the foot wall, which is this lower block here, is moving down. I really can't make this one out because it's all within the same unit. Then as we go along here, after the fault K, I have this unconformity right here, right? Which is Z to Z prime. Z to Z prime. And note that, again, we have two different angles, so it's another angular. I'll put angle there. So another angular unconformity. And then I'm going to have unit J, which is some shale, looks like a shale. And then I'd have this erosion surface U. And the erosion surface U is probably a disconformity because as I form more units up here, they're going to be horizontal. So this is going to be a disconformity. And the very youngest thing are the sediments in the river. So that'll be letter S. So there's an example of deciphering the order of events. And we can figure these out, again, using these relative time principles, common sense, right, to determine the stratigraphy, the sequence of events.